So good afternoon, everyone. Welcome back to Math 122. So today we're going to talk over section 1.2 regarding your homework. Excuse me. Regarding your homework, one of them was due yesterday, and I just posted another one today, which is going to be due on Thursday. So regarding the quiz, what I usually do for the quiz is I will pull the questions directly from the homework, and the homeworks which will be relevant for the quiz will be all of the homeworks between the last quiz and the current quiz, which have already had their due date passed by the day of the quiz. So the due date for homework 1.2 is on the day of the quiz, so it's not going to be on the quiz, okay? So there will be 2 questions on the quiz, or like roughly 2 questions, maybe 3. That will be drawn directly from the 1.1 homework assignment, which was due yesterday. So are there any questions about the quiz at all? Yep.
So when you said it's coming straight from the homework, are you talking about like exact numbers or like
No, not exact numbers, but basically like the setup of the problem will be like word for word from your homework. I'll massage the numbers a little bit so that you don't have to do any crazy arithmetic in your head because no calculators on the quiz. Does that answer your question? But yeah, otherwise it's going to be basically word for word problems from the homework, with subject to slight variation. Yep.
So is the 1.2 homework, is it due midnight on
Yeah.
Thursday?
Yeah, all the homeworks are always due at 11:59 p.m. on the day that they're due. So you have the entirety of Thursday 1/19 to work on that homework. It'll be due at the end of the day. Any other questions? Okay. Well, if you want to study for the quiz, i.e. go over some of the problems from the homework, a great time to do that would be during my office hours on Thursday from 11:30 to 1. Because you can go to office hours on the day of the quiz, keep it fresh in your mind, and then have the quiz later that day. Okay? All right, cool. So that's my office hours. I'm probably going to move one of my office hours to incorporate more students because some people have conflicts. Math Tutoring Center is always open and people are ready to tutor you there. So anything else we should discuss before we get started on content for today? Okay, then I'm going to go back really quickly and talk over what we talked about last time. So I'll go over what we talked about last time at the start of each class, and then we'll start the new stuff. So last time we talked about functions. We did some graphs of functions, we did some anatomy of function notation, and we tried to have a focus on this sort of interpretation of word problems into a mathematical context, solve a mathematical problem, and then translate back into the problem context, right? Important things regarding that were mainly what is the independent variable versus the dependent variable. That's about it. Okay, then we talked about intercepts, all right? So intercepts are where the function graph touches one of the axes, okay? So if these are our axes, then we have 2 intercepts on this function. One of them is the vertical intercept where it touches the vertical axis, and the other one is the horizontal intercept where it touches the horizontal axis. Okay? So we talked about those as well and how to find them and how to interpret them. Okay? So a lot of problems on the homework were about interpreting intercepts. So the last thing I wanted to talk about from that section really quickly before we start 1.2 was increasing, decreasing, and constant functions. So a function is increasing. By the way, if you want to follow along on these notes, I post them to the Blackboard so you can print them out. Anyways, a function is increasing, and what do I mean by local properties? Well, I mean a function could be increasing sometimes and decreasing other times, right? That's a situation that we could see. So when I say local properties, what I mean is like, well, the function is increasing in like this part of the function, but it's decreasing in this part of the function. So how are we going to describe the locations at which the function is increasing or decreasing? We're always going to describe the region of the domain, okay? So here's a function which is increasing and then decreasing. So what I would say is I'm gonna split this up into intervals. The first interval, let's say this is the number 3. The first interval would be like negative infinity up to 3. And we would say, well, on this interval, meaning for x values which lie all along this zigzag part, the function is increasing, okay? And then for x values which are bigger than that, the function is decreasing. So that's what I mean when I say local properties. So we say a function is increasing on an interval from a to b, okay, if for any x1 and x2 satisfying a is less than x1, is less than x2, is less than b. So what is the setup here? We've got a, x1, and x2, and then b. So namely, x1 and x2 are 2 points, with x1 being to the left, and both of the points are in between a and b, the end points of this interval on which the function is increasing. So if we have these collection of points and the function is increasing, okay, if the function is increasing on this interval, then what do we expect? We expect that the height of the point on the left is going to have a relationship with the height of the point on the right. And what should that relationship be? What symbol am I going to put inside this red circle?
Less than?
Yeah, less than. Like so, okay? Why? Because you can tell, okay, this blue line represents the function evaluated at x1. The height of the graph is just what you get when you plug the x value into the function. And this blue curve here, or this blue line, represents the height f of x2. And if the function's going up from left to right, then we should start lower than we end, okay? That's all that this says, okay? So, this is some sort of fancy mathematical language, but it's very rigorous, okay? Because what this fancy mathematical language allows is, look, you can take any 2 points, x1 and x2. It doesn't have to just be these ones. We could take x1 here and x2 here. Or we could take x1 here and x2 here. The only thing they have to satisfy is that the 2 points are inside the interval and one of them is to the left of the other, right? So we know which one is which. And then the function's increasing on the interval if this is true for every single pair of points inside of it, okay? So here's a function. If we take the interval of x values from a to b here, it's true that if we pick x1 and x2 here and here, well, yeah, we're increasing from there to there. But if I pick x1 to be here and x2 to be here, then in fact, I've actually gone down. So we would say that the function's not increasing on this interval because there's actually a part of the interval where it's decreasing, okay? Any questions on increasing and decreasing? Or rather, just increasing, I guess. What symbol am I going to put here if the function is decreasing? Greater than, right? What about if the function is constant? An equal sign, okay? You guys got it nailed down, okay? So going up from left to right means increasing, going down from left to right means decreasing, and going straight is a constant, okay? All right, so let's really quickly see an example here. Determine whether each table below represents an increasing or a decreasing function. Okay, so not too hard. What do we want to see? As the independent variable increases, that means we're going left to right. We want to see that the output increases, right? So negative 2 to 0, we went up 8. 0 to 2, we went up 8. 2 to 4, we went up by 56. So we went up each time. So I would say this is an increasing function. Let's see this one. Okay, 0, 2, 4, 8. From negative 25 to 20, is that an increase or a decrease?
Increase.
It's an increase, right? So we went up, and then again up and up. So I'd say increasing. All right, how about this one? Seems like, okay, 5, 10, 15, 20. Increasing, right?
No.
Okay, I couldn't slip it past Olivia. Why not?
Because the T, like, it's going backwards.
Yeah, look what's happening at the... They pulled a fast one on us, and they listed the t values in descending order. So we have to think about as we move from left to right on the graph, okay, t is increasing, and we want to see if the function value is increasing as well. But 1, 2, 3, and 4, if we're talking about going forward in time, we're talking about going from 1 to 2, 2 to 3, 3 to 4. And what happens to the function value as we move in that direction? 20, 15, 10, 5. What kind of function is this? It's a decreasing function. Okay? We happy? Any questions on this? All right. Then, okay. If you want to say, why don't we do one of these really quickly? On which intervals are the following functions increasing or decreasing? Okay, so in this type of a problem, we want to describe the numbers for which the function is increasing or decreasing. I would say it looks like it's increasing all the way up to here, and then it's decreasing thereafter. So the dividing line to me is the x value 1. So I would say that this is increasing on the interval from negative infinity up to 1. And it's decreasing on the interval from 1 up to infinity. If this is something like y equals 3 minus x quantity squared plus, sorry, not 3 minus x, it should be 1 minus x quantity squared plus 3, something like that. Okay. All right, quick question. Why did I not include 1 on these intervals? Was that what you were going to ask?
I was going to say, why didn't you put brackets next to the ones?
Yeah, Jake, right? No, you're not Jake. What's your name?
Alex.
Alex. So, great question from Alex, which I'd like to return back to the class. Can anybody help Alex in terms of why is there not a bracket on these guys?
Because it reaches 1?
Not quite.
It's not increasing or decreasing on 1, it's constant.
Can you say, yeah, well, I'm not sure if I would say that it's constant, but what I would say is, look, depending on which direction you're coming to 1 from, you're either increasing or decreasing, right? You're increasing up to 1, and then you're decreasing thereafter. But at 1, you're not going up or going down. You can think about it as for a fraction of a moment being constant. Yeah, for a fraction of a moment, where you can think about it in the following way. If I were riding a roller coaster, okay, and this is the roller coaster, and here's me riding the roller coaster, or you, right? You want to think about, well, am I pointing up or am I pointing down, right? That's the question. Well, when I'm at the tippy top, which way am I pointing? Just straight ahead and not down or up, okay? So I'm not increasing or decreasing, all right? Questions on increasing or decreasing before we move on to today's class? All right. Then we're going to go to today's class. So the first thing I want to do is get in our groups, and we're going to work on warm-up problem A. Okay, so we're working on trying to determine whether the following are functions or not functions. Okay, so I'll be walking around to help. Just raise your hand if you want a little individual attention, okay? Oh, okay, yeah. Can we talk about that?
Yeah, it goes 0 and then down and then goes back up.
Hey, so you're like,
Zero, negative 1.
Do you get A and B your functions and C and D?
Yeah. These are we're both stupid.
So good.
Yeah. I'm not gonna say that.
No, I was not good at this class.
I hate that. I'm open up really fast. It's kind of like need it.
okay, I guess the directions don't say for reasoning, but
It's not gonna be fun. Like, literally all the last semester, I was just complaining with my friends about like, yo, next semester's gonna suck ass. Yeah, take a math class. All my friends were like, oh no, it's okay, because like all my friends are in like comp sci and
Yeah, I
brains
love,
inside of them.
well, you're right. It's a good statement. We always want to have reasoning.
I'm just awful at math.
So one thing you could think of is if you were to draw a graph of that, I'd like to you have an x squared. The graph looks like x squared should be a parabola like that. We're going to learn that later. But in any case, what you could do is look at this and to determine whether it's a function or not, apply the vertical line test, right? Move your pencil left and right. See if you touch it more than one point. Okay, it's real quiet. Are we all done? I guess that probably didn't take too long. Anyone want a little more time? Okay. How about this first one? Part A, y equals x squared plus 1. Function or not function? Function. Okay, but why?
Passes the vertical line test.
Yeah, you could take a look at a couple things. First, you could say, look, I'm going to take a look at the vertical line test, okay? I know this graph looks like a parabola like so. I can draw a vertical line, and I can move it left, right, all around, and I'm only ever going to touch the function at one point, okay? So that's one reason. Another way would just be to say, look, whatever x value you put in, x squared is just a specific number. So for each input, you're going to get a unique output by squaring that number and adding 1. You'll get exactly one number, okay? That's another way that you could think about it, I guess. All right, good. How about part B? So that's going down. What do we think about this one? Function or not function?
Function.
Okay, but I'm confused because I see a lot of like repetition here. 2, 2, 2, 2, 2. Didn't we say there was a problem with repeated outputs? No, what did we say? There's a problem with repeated inputs, okay? So it's okay for the function to have repeated outputs. It's not okay for it to have repeated inputs like we have in D, okay? So no for D because 1 is going to 1 and also 1 is going to 2. That makes no sense, right? If you wanted to graph it, then at x equals 1, you'd have 2 points. You'd have the point 1, 1, and you'd have the point 1, 2, and it would fail the vertical line test because they're on top of each other. All right, how about C? Function or not function?
No.
No, because of vertical line test, right? So no VLT slash repeated inputs. Okay, questions on the warm-up problem for today? Yeah.
When would an equation not be a linear function? What would be an example of
When would a function not be a linear function, sorry?
When would an equation, like an A, for example, what would an equation, a nonlinear equation look like, essentially?
Well, you could do this one. The equation for the unit circle, actually it's not the unit circle, this length is 2, so it's x squared plus y squared is equal to, 4, right? That's the equation of this circle. Okay, so what's the difference between this equation and this equation? Because they're pretty similar, right? If we move the x squared over, we could rewrite this one as y squared equals 4 minus x squared, right? But the big difference here, okay, the big difference here is the y squared, right? If you take the square root on both sides of this equation, what are you going to get? You're going to get y is equal to plus or minus the square root of 4 minus x squared. Okay, so that's why when you get that plus or minus, you're looking at one input, okay? You could put in just one input, but you get two outputs coming from the plus and the minus. Does that answer your question? All right. Any other questions? All right, great. Then today we're going to talk about a couple things. We're going to talk about slope and linear functions, and then we're going to talk about finding the equation of a line given 2 points, and then we're going to talk about, well, maybe that'll be it. Well, maybe we'll learn something else too, actually. I don't know. We'll see how far we get. But let's start off with slope and linear functions. Okay, so when we have a linear function, we call it a linear function because it's a straight line, okay? Straight lines either go up or they go down or they go side to side. Those are basically the options. Or I suppose it could be vertical as well. So these are the type of lines that we have, and the slope of a line is a number which represents how steep is the line, okay? So if the line is increasing, we say it has a positive slope because this number will be a positive number, okay? How do we get the number? Well, you can do it in a couple ways. You can say it's the rise over the run. You could say it is, you may not have seen this notation before, delta y, capital delta on top and capital delta on bottom. Delta means, in math, delta means change in, or total change in. Okay, so change in y, that's the rise. How much did we go up or down? That's the rise, right? Change in y. Change in x, how far over did we go? Okay, left and right. All right, so delta y over delta x, and then we've got another way of thinking about it. This says the exact same thing. F of x2 is the height at the end point. F of x1 is the height at the beginning point, right? So you subtract the heights, and then you divide by subtracting the widths. Or if you want, you could say y2 minus y1 over x2 minus x1. You might have seen that before. Okay, so that's the slope. And the letter we use for the slope is always m. So if we have a linear function, let's put it together with slope-intercept form. We have y is going to be equal to the output of our function f of x, which is going to be equal to, we take the slope times the x value, and we add this number b. Okay, so here m is the slope, and b is, well, think about what would happen if I took this function and I plugged in 0. If I plugged in 0, then m times 0, well, anything times 0 would be 0, and it would go away, and we'd be left with just b, right? So 0 comma b is going to be on the graph of this function, which tells us what kind of intercept is this if the width is 0.
Y.
It's a y-intercept, but what was the word we used for intercepts which are?
Vertical.
Yeah, we use vertical intercepts because it might not necessarily be y. In this case, it is y. So this is going to be our vertical intercept. And this whole thing we call slope-intercept form. Okay, y equals mx plus b. I think probably most people have seen that before, if not all of you. So m's the slope, b is the vertical intercept. Okay, so let's just maybe say one more thing about lines, which is they're really defined by this rate of increase, okay? In fact, the rate at which we are increasing, or rather the steepness of this function, is constant, right? Whether I'm standing here or whether I'm standing here, right, the steepness of this path is always the same, okay? So if I walk however many feet in the rightward direction, I know exactly how much up I'm gonna go, okay? How much up I'm gonna go based on how far to the side I go, okay? These sentences don't make sense, but you'll see what I mean when we try to determine whether the following tables could represent linear functions. So I'm gonna do this one, and then we're gonna have some group work. Okay, if I can move the screen. So if we want to determine whether their functions are linear functions or not, okay, linear means for each increase, okay, it should be proportional to, the increase in height should be proportional to the increase in x value, okay? So what did we do from here to here? We went up 25, that was our rise. And we went over 100. So 25 over 100. Then the next step, we did the same thing, right? Up 25 and over 100. The next step, what did we do? Up 25 and over 100. So what do we think? Is this a linear relationship? Yes, because all these numbers are the same. Okay? All right. Let's do a different one. Well, this one, what did we do? We went up 10 over 5. And then what happened? Up 6 over 3. And then, what did we do? Up 14 over 7. So, based on my observation, these numbers are not the same, and therefore it's not a linear function. Agree or disagree?
Disagree.
Okay, good. We disagree because even though the numerator and denominator of these numbers are different, they represent the same number because they can all be simplified to 2, right? 10 divided by 5 is the same as 6 divided by 3, is the same as 14 divided by 7. Were you happy? You looked concerned for a second there, Stephanie. You all right? Okay. Didn't mean to single you out. Okay. So this is what how we do that. So let's see an example. Okay, come on. They gave us 3 examples. 2 of them were linear. The last one's probably going to be not linear, right? So let's verify that. Up 20 over 12. Up 10 over 12. I don't even need to check the last thing, do I? Right? Because these 2 numbers are not the same, therefore it's not linear. Okay? Any questions on that? Checking from a table? All right. Then let's see one that's more complicated. Okay, I'm going to do part A, and then we're going to do part B as a group. So now we're moving into word problems again. So we have an icicle is growing according to the formula W of t equals 0.2t plus 0.15, where t is measured in time in hours, okay? Oftentimes I like to highlight or underline the sort of relevant bits from this, okay? Words like since the first, okay, actually that is important. Since the first measurement was taken, okay? That tells you what t should be. But a lot of these words are basically not that important. So I like to highlight the stuff that is important. What do we have? W is the width in centimeters. Okay, so now we know all of our units, and we have our function which relates these 2 quantities. What's the independent variable here? Time. Time is always the independent variable. Also, whatever variable is inside the parentheses is the independent variable, okay? All right, so for this one, what are we supposed to do? Find and interpret the slope and the vertical intercept. Well, the slope, this is already in slope-intercept form, so it's real easy to see what the slope should be. M is just going to be 0.2. It's whatever number is attached to the independent variable. And then B, the intercept is 0.15. Okay, that's the vertical intercept. All right, so what does it mean in the context of the problem? Well, 0.2 is the rate of change, okay? It's the rate of change. So what it's saying is, first of all, it's a positive number, so over time, my icicle is going to grow, okay? And the 0.2 is going to represent how fast it's growing, okay? How fast it's growing. So you could say it in a handful of ways, but the way I would like to say it is, look, if t goes up by 1, okay, if we have a run of 1, what's the rise going to be? If the rise over run equals 0.2 and the run is 1, then what was my rise?
0.2.
Yeah, 0.2, because anything divided by 1 is itself. So this is telling me, look, each hour the icicle grows by 0.2 centimeters. That's one way you could say it. Or you could say it's growing at a rate of 0.2 centimeters per hour. Something like that you could also say. All right, how about the intercept? How do I interpret that? Yeah, so the intercept, okay, has coordinates 0, 0.15, where 0 is representing the t value and 0.15 is representing the w value, right? So if t is 0, that means it's the point at which we started measuring. So at the beginning of our experiment, what was true? The icicle was 0.15 centimeters long. It's a really small icicle, actually. 0.15 centimeters is like 1.5 millimeters. Yeah. Anyways, you get the point. Any questions about part A? All right, then let's work in a group on part B, and I'll be walking around to help, okay? Can you two work together, please? Thank you. Yeah, it's because you can do addition and 3 plus 1 is the same as 5.
So it's like to one body. Like, it's gonna start at $10,
there's an automatic $10 charge per
Yeah.
month, and then for every megabyte you use, you get charged $2.65.
So what is you have two variables, we've got one N and C, right? So which one of them is N, which one is C? If we use 0 megabytes, then C represents total charge in dollars. I get it. I don't use any of my megabytes. Hey, what's up? Great, so in this case, actually, we're not talking about like a certain number of months. How much does it cost per month if I use a certain amount of data?
No, I know. My friend like snapped me and was like, dude, I'm not a research it and go back to sleep. And I was like, dude, I just gotta make a calculator and go back and slumber, dude.
And I slept for like literally 10 hours last night. I woke up so late.
I woke up at like 9 and got out of bed for that much.
I didn't get out of bed until like 10:30.
Just like laying there praying and I felt like I was asleep, but I just couldn't. Tell me about it. I like my friends and I were like, oh dude, like
Yes, good.
Good?
yeah, we were like,
How's it going over
let's
here?
go to like Greenville and go to the malls if you're bored. And so we went there and we kept on seeing all the signs like, yo, you keep going, you go to Atlanta. And we were like, how far would it be if we went to Atlanta? And then we get in the mall and we're like, yo, let's go to Atlanta. So we went to Atlanta.
That's actually really fun.
And then like my friend had us take this like lame ass route home, and we ended up going through Augusta, like to get home. So I was like everywhere.
Yeah.
It was crazy.
No, I'm trying to convince my friends to go to rally for the when the hurricanes hit the ruins. Because I want to see the ruins.
Yeah.
But they're like, we're not driving 3 hours to go to rally. So I'm like,
No, it was so much driving. But like luckily I like driving. Like all my friends were driving and things like that. And it was cool. I got to see a bunch of like goofy stuff, like the Mercedes-Benz Stadium and stuff.
oh my god.
Yeah, it was
I
crazy.
remember Atlanta so bad.
It was really
I've only ever been like an airport.
I went like at night and like we saw this giant line of people like crowded outside of like this like the Fox Theater
Yeah.
and like we're like people are just piling in. They must have been going to premiere and like the cars that were pulling up was already literally this guy like the chauffeur dropped off like 3 people in a Rolls Royce.
Like LeBron James.
No, literally, this is like one of like 3 Rolls Royces. I was like, it was like heaven. Like, everybody has such cool cars.
So let's say that N is 0, right? So if I put it, plug in a 0 right here, then we would get just C of N is equal to 10 plus 0 is 10, right? So what does that mean in terms of the plug-in? 0 is N, which means we use how many megabytes? No megabytes, right? And then how much does it cost per month if we don't use any megabytes? Got it. What about if I use 5 megabytes? Yeah, exactly. And that's how you get the new cost. Okay, so let's read this right. What do I say? It says, for each of the following situations, find and interpret the slope of the interception. So we already did the interception. That was namely to say, look, if you don't use any megabytes, you pay $10. How about the slope? That's this number, 2.05. What does that mean? Well, the slope tells us how much do we go up and we go over, right? So going over means using more megabytes. Going up means costing more dollars, right? So 2.05 here in this case means what? Yeah, so like for each additional megabyte purchased, how much we gotta pay for it? $2.05. Make sense? That's okay. We can talk about it after class. Or maybe this will help. We'll discuss as a class. Okay, we need a little more time. What, you got a question? What's the question? Or you don't want to say?
Nah, I just like, I don't know what, I'm just confused about the months aspect, because basically what the equation is saying is if you were to have like 0 megabytes, it would still be a $10 direct fee, right? So for every megabyte, it's $2.05.
For each megabyte, it's $2.05 past your initial $10.
Yeah, so like if,
Right.
let's say you got let's say you just got 2 megabytes for the month, right? Because we're talking about months, it would be $14.10.
Yeah.
Oh, okay.
Yeah, you got it right. Yeah, so, okay, I think part of why this is confusing is you're thinking like, well, where is the role of time in all of this, right? Because they say month, but there's no T, right? So you might think like, oh, well, like, is this like a month over month type of thing? No, we're only ever actually trying to describe the price of one individual month, okay? We're just trying to say, look, for 1 month of service, the amount that you pay at the end of that month depends on how much data you use, right? That's all we're saying. Does that help answer your question?
Yeah.
Okay. So let's interpret the slope and vertical intercept. So don't be confused because they put it in reverse order, right? You can add things in any order that you want, right? You can do 3 plus 5 is the same as 5 plus 3, okay? So in this case, the slope here is what?
2.05.
2.05. And what does it represent in terms of the problem?
How much you're charged per megabyte?
Yeah, price per megabyte, basically. Okay, and how about the intercept? What is the intercept? What does this number represent in terms of the problem?
Your base fee.
So I hear a few different things. So one thing that I'll say is for the intercept, okay, what we want to remember about the y-intercept or the vertical intercept is that on the graph, okay, of this function, the vertical intercept is the spot at which the graph touches the vertical axis. Now, if we touch the vertical axis, then we actually know what our horizontal coordinate is. The horizontal coordinate has to be 0. So this is the point 0, 10. So that tells us that the input of the function is 0. The input of this function is n, so n should be 0, so the number of megabytes is going to be 0. But what does it mean for the output to still be 10?
That's your base fee for the data plan?
Yeah, base fee just for having the data plan. Okay? So it's $10 per month if you don't use anything. Okay? So, whoops, not 18, but $10 base fee. I like that way of saying it, base fee. Okay? And then for each additional megabyte that you use, you pay an additional $2.05. So like Alex was saying, if you use 2 megabytes, then you pay $10 for the base fee plus $4.10 for your 2 megabytes. All right, any questions on this example? Let's have some thumbs out there. Raise them real high. Thumbs straight up in the air if you feel like you could ace a quiz on this today. And straight down if not so much, and middle if you're middle. Okay. Well, few middles, but hopefully the homework will help you to learn it a little bit better. Okay? That's the thing about... Yeah, question? Okay. No worries. Yeah, so homework will help you learn this stuff a lot better, okay? Look, math is like any skill-based thing, right? Like if I want to get really good at tennis, okay, it's not enough for me to just go and watch Roger Federer play tennis. That's not going to make me good at tennis. I'll certainly look at it and I'll say, oh, that guy's good at tennis. But for me to get good at tennis, what do I have to do? I have to go practice, okay? Same thing with math, okay? So that's why the homework is there, okay? It's not really something to like check whether you know something. It's something for you to help yourself learn how to do it so that you can do it on the exam, okay? All right, that's my spiel on tennis. So let's talk about finding the equation of a linear function. So the very first thing we have to do before we do that is to find another way that you can write the equation of a line, which is point-slope form. Okay, and point-slope form looks like the following. The equation of a line with slope m, and this time we're not going to say what the vertical intercept is. We're just going to say it has slope m and passes through a certain point. Passes through x naught, y naught. So when I put a 0 here, I'm no longer talking about variables, okay? I'm talking about a specific number, okay? So x naught is a specific number that doesn't change, okay? So you can write it as y minus y naught is equal to m times x minus x naught. Okay, that's how you can write it. So in the special case where you're going through the point 0, comma b, as is the case in slope-intercept form, then we would put the b here and the 0 here, move the b over to the other side as a plus b, and you recover the original slope-intercept form. So nothing crazy here. All we're saying is you can think about this in the following way. If you look at the equation of a line, which passes through the point x naught, y naught, then what is this? This is the difference in height between the point that it passes through and some other point on the line. So you're looking at this distance of this vertical segment. Well, what is that distance going to be? It's going to depend on how far over you went, right? So that's m, the slope, times this distance corresponds with this distance corresponds with this distance, right? So all it's saying is, look, the amount I go up is the slope times the amount I go over, okay? Just another way of writing it, really. Any questions on point slope form yet? Yep.
So is that the same as saying y1 minus y2 and x1 minus x2, or no?
So a little bit. If we say it's for specific x2, y2, okay, then we're talking about one point on the line. But the equation is supposed to say, look, all pairs of x and y, such that if you plug them into this, you get an equality, that is the collection of points which lie upon this line, okay? So in this sense, we're saying something a little bit more general than that. We're saying, look, x and y can be anything. This is either going to be true or not true. The points for which it is true, we call those points on the line, and we say that they are on the graph of the line. But that's getting a little bit philosophical at this point. Does that answer your question? Any other questions? Okay, let's see how we actually use this business. Well, let's go ahead and try to find the equation of a line which passes through 2 points. Keep an eye on my time here. Plenty of time. So, what do we want to do here? We have y equals negative x squared plus 4 is the graph of this function, and we're supposed to find the slope of, we're actually supposed to find the equation of this line. Okay, so what are we going to do? Well, we're going to try to find 2 points on this line. If I have 2 points, then I know how to find the slope using y2 minus y1 over x2 minus x1, which we learned earlier. Once I have the slope, the only other thing I have to do to write the equation of this line is to plug in that slope right here for m, and then plug in one of the points for x0 and y0, okay? So I'm going to say arbitrarily, like completely arbitrarily, that this point here is the point x0, y0. And I'm going to call this point over here x1, y1. Or if you want, you could do x1, y1, and x2, y2. It doesn't really matter. Okay, but now I need to know what these numbers are. I claim that you already know what x0 is. What is x0? Yeah, -1. It's the x value of this point, which can be seen below. It's -1. So this is the same as -1, comma, what about y0?
You have to plug it in.
Yeah, you can, y0 represents this height, or if you want, you could put it as a tick mark on the vertical axis, right? That's y0. But I want to know how high that point is. I want to quantify that. Well, the way you get the height of the function is by taking the input, the x value, and plugging it in, okay? So y0 is going to be equal to negative x0 quantity squared plus 4, which would be negative, and we got to be careful here, because what are we supposed to do here? PEMDAS says we square this thing before applying the minus sign. So we do -1 all squared and then make it negative, and then we add 4. So that to me is -1 times -1 is +1. So we get -1 plus 4, which is 3. So that's how I get this point. Any questions on that? All right, I also need the coordinates of the other point, though, so that I can find the slope. Do I know anything about these coordinates of this point? Yeah, the y value is 0. I know that much. So let's see. I'm going to put 0 here. Or why don't I say this is equal to something comma 0. And now how am I going to figure out what x1 is? Yeah, I'm going to solve for x in the equation. So 0 is going to go in for y. So I'm going to do 0 equals negative x1 squared plus 4. Now how do I get x1 by itself?
Add it to the other side.
Move it over to the other side. So I get x squared equals to 4, and then I do the square root. Is there anything I need to be a little bit careful about here? Or are we happy with a statement like this?
It's positive or negative, square root of 4.
Yeah, we have to be a little bit careful when we do a square root. There's always 2 of them, okay? So plus or minus. But this point here has an x coordinate, okay? I need to pick one. Which one should I pick?
Positive.
The positive one, right? You can see exactly why this happens, by the way, because guess what? You're asking, what is the x value of a point whose height is 0? Well, guess how many points have height 0 on the parabola? 2 of them, right? One of them at +2 and one of them at -2, okay? So this is the point 2 comma 0. All right, so that was a little bit convoluted, but finally we have 2 points on this line. So given the 2 points, which are -1, 3 and 2, 0, here's how I'm going to find out the equation of this line. The first thing I'm going to do is take care of the slope. I know I need to figure out what that slope is. And the way I figure out the slope is by computing the rise over the run, okay? So, rise has to do with the y values. So in this case, I'm going to do 0 minus 3. That's the rise, okay? y2 minus y1. Then I'm going to divide. In fact, why don't I write y2 minus y1 over x2 minus x1. Or if you, actually, I think I used 1 and 0. So why don't we do 1 and 0? And x1 is 2, and we subtract from that negative 1, which means we add 1. So the slope that I'm getting is negative 3 over 3, which is negative 1. And that's m. Now what remains to do to find the equation of this thing?
Plug it in the point forms, or slope form.
Yeah, exactly. A bunch of people said it. Plug it in to the point slope form. Well, I'm going to put in m is just negative 1. And what's going to go in my remaining blanks? Yeah, one of the points. Does it matter which one?
Yes.
Let's see. Let's see if it matters which one. Well, we'll try both, and we'll see if we get the same thing. Well, if I plug in the first point, which is negative 1 and 3, I'm going to put a 3 here, make this a plus 1, okay? Let's take a look at this line versus the other one. The other line is y minus 0 is equal to negative 1 times x minus 2, right? So these are the two lines we get. But what do we notice about these lines? They're actually the same. Okay? How could that be? Well, you distribute out the minus 1 here. What would you get? Let me move this down. If you distribute out the minus 1, you'd get y minus 3 is equal to negative x minus 1. And then you would add 3 to both sides, and you'd get y is equal to minus x plus 2. In this one, if we distribute it out, we get y equals minus x plus 2. So actually, they are the same. And at the end of the day, you can use any point that you want for x naught, y naught, okay? The most important thing is that you calculate the slope correctly, and you're consistent among your use of, you don't use x naught with y1, or y naught with x1 or something like that. Okay, we've got to use just one point on the line plus the slope of the line. That gives us the equation. All right, any questions about this process? There's something else I wanted to do here. Okay, let's see. I prefer to do this one as a group problem, I just decided. So let's work on problem 4 in our groups, okay? And we'll do like maybe one more thing and then close for today. So please work with a partner on problem 4. And I'll be coming around to help.
No, it is. Believe me, it is.
Okay.
No, I think it's funny.
Okay.
Well, I'm still going back.
Right, that's how we get the order pairs, right? It's the height of the point is gonna be what you get when you plug in. So what are our two order pairs? Exactly, right. Okay, so now we got our two points. So what do I need to do to get
But like here, like when you're finding the slope.
Slope is the first step, right? So how do I do
Yeah,
that?
so you would, yeah.
Well, we're gonna eventually use
What's
point
3/4
slope.
divided by -3?
But if I just have 2 points, how do I find like how? Rise over run, right? So rise is the difference in the outputs. That's the input in this case. Yeah, a -1, but yeah.
Okay.
See what I mean?
Yeah.
Okay, so. We found our situation, right?
Wait, how do
Subtract, make it as tight, and then up here. So yeah, whatever this is.
No, this problem's making my brain malfunction. Not my brain is just having a problem grasping the concept of the problem.
So that's the next step. Right? But now we gotta get around to the equation of the line. We got the slope. What else should we do? Could be slope intercept or probably it's gonna be easier. We don't know what the intercept is, right? That's the There you go. Well, I guess that's fine formula for the line, so that's specifically.
I'm not excited to get to the calculus.
Yeah, once I see a derivative,
Oh, no,
my fucking brain is gonna pop. Remember when I saw derivatives for the first time I freaked out about it?
So what are the classic derivatives called? Integrals. Yeah.
Actually, I'm hurt. You know, I was having fun for a second, because I was like, oh, this is what I know.
You would need a formula. I didn't but you just get stuck in one, you get yeah, that's a different curve. Okay, so we'll 1 over t squared plus 7. Okay, okay, so what you're doing is you're taking a point somewhere here, and then you're taking another point somewhere else, right? And then you're like trying to combine them and find this line. So this line is going to pass through the vertical axis at a point that has nothing to do with the function 1 over t squared plus 7. Does that make sense? Yeah, go ahead.
Oh, it's in mine. Like this catch up now.
Okay, so what did we do? We figured out what is the height for these 2 points, right? So now we can write these as 2 ordered pairs, right? The first ordered pair being -1, and the second ordered pair being 2, comma 29. If I have a line which goes through these 2 points, do you know how to figure out the slope? Did you get weirded out by the number? Okay. But you know how to proceed from there? Yeah, looks good. This is an equation, right? Just you put in the y naught, you put in the x naught, and then the m, so you're all good. Well, it needs to be minus -1, which is the same as +1. So yes. Y'all have another question? Pretty good and you don't need to simplify because when you read the instructions, right, it just says find a formula to line. It doesn't say specifically like literally slope or so or anything like that. If it did, then you have to simplify further, but point slope forms are perfectly fine. Yeah.
The one up on the big that's frustrating.
This looks promising. So, right, we've got the 2 points here, right? -1, 2, 29. Right, exactly. But that's the thing is, we're just trying to use yeah, points. So, we found the slope, and we know the point of the line. We're going to take m, and we're going to put it in here. And then we're going to take -1, we're going to put it in there. We're going to take 8, we're going to put it in here. No, in fact, what are you going to get if you plug into 0 to 1/t²? Right? And you're like, oh, I'm adding by 0. But okay, we'll explain this in a second. Okay, let's come back as a group. I had a lot of excellent questions. It seems like this one teased your brains a little bit. So let's see what's really going on here, okay? Because I saw a lot of people doing similar things. So, first of all, let me show you what this function looks like. Although you don't need to know what it looks like. But 1/t² plus 7 looks something like this. Okay, something like this, probably. Okay? And what we're trying to do here is what? We're trying to find the formula for the line which intersects the graph of this function at t equals -1 and t equals +2. So let's put those on here. Here's -1. Why don't I do it here? -1, and here's +2. So here's the point, -1 comma h of -1. And then there's another point down here, which is the point 2 comma h of 2. So, my goal is to find the equation of this line, which looks like so. Okay? But you don't need to actually have any knowledge of what this weird-looking function looks like in order to do that. This is just to help illustrate what's really going on here. So all I need to do is to know what are these 2 points. Then I can figure out the slope between them and use point-slope form to find the equation of the line. So the very first thing I need to do is to find the slope between these 2 points, which is, well, I need to calculate the rise over the run. What's the rise in this circumstance? The rise is whatever is the difference in the y value. So h of 2 minus h of -1. Yes? And then we're going to divide that by 2 minus -1, which is +1. Okay, but here's the problem. I don't know what h of 2 is, and I don't know what h of -1 is. But I can figure it out. How do I figure it out?
Plug them into the equation.
Is that what you were going to say? Yeah. Okay, so both of y'all got it right. We're going to take it and we're plugging it into the equation. So 2 goes in right here. we get 7 1/4. And then we're going to subtract from that 8. Right? And then we're going to divide by 3. So that is negative 3/4 divided by 3, which is the same as negative 3/4 times 1/3, which we cancel 3, and we get negative 1/4. Okay. Sorry, did I go too fast there?
No.
Let me go. Okay, so what is happening here, right, is now I have the slope of this function. Now, what you might be tempted to do is rely on your understanding of this equation, mx plus b, and say, okay, now I need to figure out what b is. Perhaps by plugging in 0, right? But you got to be careful here because this line is not going to have anything to do with what's going on with this function when the input is 0, okay? In fact, if you try to plug in 0 into this function, you're going to get 1 divided by 0, right? Which is not okay. So rather, we're going to use our point-slope form, which says, look, all you need to know is the slope and one of the points on the line. Doesn't matter what point. So, in this case, we could use the point, this point, or we could use this point. I'm going to use the point corresponding with negative 1 because I think the output is like 8 or something nice like that. So for me, all I have to do now is y minus y naught. So this is y naught, and this is x naught. So I get y minus 8 equals negative 1/4 times x plus 1, because minus negative 1 is plus 1. Okay, and you can leave it like that. This is a formula for the line. If you want to simplify it, go ahead, but totally not needed. All right, we'll stop there for today. If you have questions, stay after class.